Good morning to everyone that has just joined us, and hello to anyone that may be watching the replay. Welcome to another one of our online learning webinars. This time it's all about to pin or not to pin, buildings on the move. I'm your host, Andy Ferguson, and joining me today is Director of MJ Rooney, Cormac Rooney. Good morning, Cormac.
Morning, Andy. How you doing?
Not bad. It's been a while since I've actually seen you. The last time I saw you was up in Bonnie, Glasgow.
It was indeed. Yeah, it was a good day out, that.
Yeah, no, it certainly was. It certainly was. Now, just for those that are just joining us, if you missed me there about how you can ask questions, if you do want to ask questions over the course of the webinar, you firstly use our chat facility that if you're on a desktop, will run either down the left or the right-hand side of your screen. There's a chat box. Simply pose your question in there, or if you just want to say anything over the course of the webinar, or if you disagree with anything we say over the course of the webinar, then voice your opinion. Tell us what you think. If you do want to pose questions in other ways, you can pose a question either via email. Simply just email me at andy@property-care.org. That's andy@property-care.org. Or use one of our social media channels, either Twitter, LinkedIn or Facebook. Simply just go to the native search functionality there, find Property Care Association, and simply pose your question that way. So I can see, Cormac, we are literally just about to turn 9 o'clock. So subsidence, it's a term, I suppose, to a lot of us, it struck fear into many surveyors and evaluators, especially back in the 80s. I know we've all gained a better understanding over the years of how we can better respond to it, and principally the main response mechanism has been through underpinning. But you and I both know, and as the world also knows, mistakes still happen. Subsidence is still very much alive and well. But when is it right to consider underpinning? And when is it right to use it as the solution? And what investigations and structural surveys should actually be done? Some big questions, Cormac. I suppose I'll pass it over to yourself, good sir.
Very good, Andy. Thank you very much. Yeah, it's a pleasure to be speaking on this. I've been involved in underpinning for many years, from digging the pins in the first place for Dad and the company and my summers and everything, right through to working as a loss adjuster for the insurance companies when I was just finishing up university. And obviously as a contractor and a basement contractor. So I'm going to go through everything. I'm going to go through basically what is underpinning to start with, the problems that go wrong and why you might need to underpin, and also some other things that you might think need underpinning, but they're not related at all. I'll look at insurance claims and investigations, what happens when it goes wrong, like what happens to structures, but also, unfortunately, with people sometimes it can be quite dangerous situations. I'll go through party wall. I'll go through things we might dig up, like some of the historic structures, unexploded bombs and things like that. Look at how we use 3D and 4D modeling, augmented reality and things like that to help us with our underpinning. Also look at some alternatives to underpinning. So digging holes and filling them with concrete is not always the way to go. And of course, some of the problems that we'll come across, like free line can be a massive issue in basements. What happens when we're underpinning below water? So we'll start with the definition. This was from Wikipedia, which would do underpinning is the process of strengthening the foundation of an existing building or other structure. So we can see three typical types here. We've got a traditional mass fill concrete on the left. We've got pile and beam in the middle. So you'll put piles in the ground either side of the wall at say 1 meter centers, pour a concrete beam through and then separate that building from its old foundations. And on the right, the bit that we like here for basement underpinning. Now, interestingly, on that one, it's got a concrete heel on that pin, and that's something that we don't like to see as contractors. I'm not sure it's really needed in that structure. I'd say 95% of cases now we don't have that, but sometimes we have to argue it out to try and get that out of the design, because you have to undermine your earthwork supports to put that in place. If you've got water coming down, it's very difficult to prop horizontally and get the quality that we need in both the temporary works and the structure. So why would you underpin? So we've got building foundations movements or subsidence. Maybe you want to add another story onto a building and you need stronger foundations, forming a basement, of course, which we like to do. Or maybe you're putting a pipe down the side of a building and you're in danger of undermining that structure to get the pipe in. So you might want to underpin that building first of all. So I got these from Hamilton Fraser. These are really good little images just to explain it. So heave when the ground is pushing upwards. And if you look at the cracking on that photo there, you can see it's wider at the bottom, narrower at the top, and it gives a clear indication of the direction of movement. With landslip as well, you'll normally see a building on a sloping site, and you can kind of see that building moving towards that slope, bigger cracks at the top, smaller at the bottom. Subsidence, as you'll see here, so I think that that tree would have something to do with what's going on in that building, but you wouldn't really see it in the ground itself. And settlement, you would hope you're not underpinning for settlement, so new buildings would always move a little bit, but you'll hope they're designed and built to a good enough quality that you shouldn't see that cracking. Or if it is, it's just minor cracking in the first year within the structure for drying out. So sulfate damage, it can look like subsidence, but it's not. That's when water gets involved with the lime that's available in that concrete. You can see thermal movements here. Maybe the sun is shining on that facade. The other facade might be colder, and over time that would build up into a crack. It should be equal in width top to bottom, and it just expansion joints in there obviously would have sorted that issue. No need to underpin, and just like this one here, this is a lintel failure. It could be coincided with the sort of failures you'd see for subsidence, but if it's just an arch like that, you just need to rebuild it. Certainly no underpinning needed in place. So when I was working at Ellis and Buckle, and that became Cunningham Ellis and Buckle while I was there, these are the investigations that we would always be doing. An engineer would have a look first and see, does it look like subsidence, the crack profile. We do soil testing to see the type of soil. Is it clay, highly shrinkable? You might find roots in that, and you'd send them to the lab to know exactly what trees they came from. Arboricultural report to see the trees, what size they are, is there more growth left in them trees? And drain testing, of course, because in a lot of cases you'll have a look and you've got leaking drains. That can be softening the ground below the foundations, but also washing out the fines out of the subsoil. So maybe if you put a drain liner in there, that's your solution. Certainly not getting into underpinning in that case. So the biggest culprit I think you see is tree damage. Now on that building on the right, I think that that tree would be lifting that building up out of the ground for its root growth. But the biggest problems that we see is when the tree is a few meters away. And particularly around London and the southeast, we've got highly shrinkable clays. The roots of that tree will get in underneath those foundations, will desiccate that soil. Particularly in very long, hot summers, you'll see more damage, more insurance claims coming up in those kind of instances. And then during the wetter seasons, you'll see if you're monitoring the cracks on that building, they'll close during the winter time. And that's a clear indication it's the trees. So I saw this tweet here. I thought it's the researchers, the Clay Research Group, Tamala Trees, a local arboriculturist put that up. And I never realized this. I knew that willows cause a hell of a lot of damage. So even from 40 meters away, a willow can damage a building with subsidence. But conifers, if you have a look on the tree height and the tree count, how much damage conifers are causing. And I know why this is happening. People move into a house, they want some privacy. So they plant some trees. Within a couple of years, they get that privacy. But within another couple of years after that, they get subsidence damage to their house in lots of cases. So before or the invasive weed group get hold of this data and put that on the list, if you just manage those trees, or if you just pick a different type of tree to get you that privacy, maybe wait a little longer, it might be a much more sensible approach. So what happens when it goes wrong? I see these every few months coming up. Maybe it's because I'm focused on them, but it's quite technical, underpinning a house and forming basements. And there's lots going on around London, and you see little damage stories coming up all the time. So that one there from a few years ago, I think they were underpinning vaults in the street. So they were digging out. They obviously haven't put any support in there underneath, but they're also adding the weight that they're digging out on top of them by putting it onto that skip. And that one on the right, now I believe that was not just one house, but two apartments. You've got an upstairs and downstairs. Downstairs want a basement. Upstairs probably didn't want them to build a basement, and the contractor that they selected obviously hasn't done their job right. They had a right to support, a legal right to support, which wasn't gone. But you want to make sure that your contractor has the insurances in place, which I don't believe is the case in this one, just to make sure that you're protected like that. So what do you do before you start digging holes? These people on the right, obviously, they just pick up a shovel and dig a hole, but we can't do that for lots of reasons. We wouldn't want to do it because they're in particularly dangerous situations there. So we would have structural calculations for the building, what we propose to do. You would need building control approval. We probably need party walls in place. I'll go through a little bit of that. An asset search for the services that are below the ground to know that they're not in our way and to see where the dangers are. Soil investigation reports, of course, trial holes, maybe an asbestos survey for pre-2000 buildings. A structural survey to make sure the underpinning itself is going to be safe to do, that the buildings are okay for that. You've got unexploded ordnance, particularly lots around London, listed structures, archaeology, all the health and safety and temporary works procedures and setting out sequences that we need to do. Now, that guy that you see there in the picture, obviously all of this health and safety and everything doesn't apply to him because he's in the Congo, but he is part of our supply chain. And I think we've got a responsibility to make sure that the steps that we're putting in place for ourselves over here go into our supply chain, and we may end up just paying more for what we need. But that cobalt, ironically, is to make the tools that we need to do our job safer. It's for our mobile phones, it's for our EVs and stuff like that. So we've just got to keep up our responsibility on that into the future. So party wall awards. If you're underpinning the wall between you and your neighbour, you'll need a party wall award. And outside of that, you've got other rules. So you've got a 3 metre rule and a 6 metre rule that you see here. So if you're less than 3 metres from that boundary, if you're digging to the depth of your neighbour's foundations, you'll need to do a party wall award. And within 6 metres or 6 metre distance there, draw a 45-degree angle from the base of that foundation from where the loading is. If you're cutting through that, then you'll need a party wall award there. So what needs to be done for a party wall award? Well, we don't want to see what you see on this photo here on the right. You'd serve a notice to your neighbour. Now, you can download this form and do that yourself, but I would strongly advise that you get a party wall surveyor to do that for you. Now, they can just sign that and give you consent. It doesn't take away from their rights. You can still do a condition survey. It just means that you can go ahead with them works, or they might dissent, and in which case your neighbour might appoint a party wall surveyor. You would appoint a party wall surveyor. Each would work for opposite sides. But we've seen cases where there's blocks of flats and they're all under individual ownership. So you could have 40 party wall awards. Is that 40 party wall surveyors? I suggest that that surveyor is working on behalf of the wall and not for either party. So if they're doing their job right, you should only really need one party wall surveyor, I think, in most cases. So asset searches, we go to British Gas, UK Power Networks, Thames Water. They'll give you an asset search to tell you what services there are in the ground, which is a good starting point. You can see in that photo, we have classroom training. We will pull everyone from all of our sites into one place, and we'll make sure everyone gets trained on how to use Cat and Jenny. So we send a signal down through the services and we'll locate them on site. So the first thing we want to do is a hand dig. Find them services, log them in a couple of locations so we've got a reasonable idea of where they're going, and to keep up that checking as we're going through that process. Another thing to note is doing trial holes. Some jobs go ahead and we don't have the information on that trial holes. I think it's awkward to go into someone's house while they're living there and dig holes, but it really is worthwhile. Certainly lots of holes, one on each elevation, I think is advisable. We've come across jobs before where you start to do the underpinning works to form a basement or something and you find out the foundations are completely different. So the engineer needs to revisit their scheme. We need to revisit the temporary works, and you need to go back to that party wall award. So you can get huge delays that would come out of that. So as much information gathering as you can right from the beginning. Right, bomb site. This is a really good website that you can go to. So there are all the bombs that landed around London in the Blitz. That's just by our office, and I can see about 4 or 5 in the vicinity of where we are. So if I was looking at an underpinning project or a basement build, I would check that website. Now, if I'm very close to one of them bombs, then there's a good chance that other bombs fell nearby, maybe that didn't explode. Or even if it was very close to that, there would be quite a risk of contamination in that soil. So you might do a little bit of extra testing on that. Quite often, if you get a soil investigation report, there'll be a desktop study that's done with that. So that might identify the risk of unexploded ordnance in the ground. If there was a low to medium risk, we would have an expert come into the site on ordnance. They would get the team together and we would get training. And that would be showing these kind of photos here, telling us the type of ordnance that we might come across. Now, if we're medium to high risk, I think we would probably have a watching brief in place. That would be what the risk assessment would probably throw up, which were done by third parties. And they would just be on site while we're digging. They would just be drinking tea and walking around. But believe me, if you did find one of those devices, we would all be gone and they would be left to deal with that. So it's just all about reducing risk as much as possible. We've never dug up any bombs, by the way, but you do see it in the news. So a note on listed buildings and archaeology. It's worth checking if a building's listed, but also if you're next door to a listed building, because that can be just the same. And you'll need listed building consent if you want to underpin those buildings. And just to note that if you just say, well, I didn't know, it's not an excuse. You cannot use that as your defence. So you will be committing a criminal offence by doing those underpinning works in that case. Also to note, for treasure that's found or any archaeology, you've got an obligation to report that as well. Now, when I was digging pins years ago, I used to dig up lots of stuff, lots of bottles, particularly when it was around rivers and you had lots of gravels. So we'd find old pipes and stuff like that. Nothing of any real value. I've not heard of anything really reported to me since. No one's come to me and told me they found a box of gold or anything like that, but there is an obligation to report that. So this is the sad side of what we see. If you have a look on the right there, look at that shoring that's in place for that underpinning. And that was a fatality on that site. This data was from the HSE, another fatality site that you see there. So some people are going to work and they're just hugely let down by their employers, which is just really sad to see and something that we can definitely avoid. That one on the right there, this is the type of thing that can go on. Look, what's the easiest way you could possibly dig a basement? Put a big digger in the middle, dig out all the volume, and then start to put concrete in each side. But you're putting lots of people's lives at risk. You're putting that building and the neighbouring buildings at risk, and the occupants of those buildings. So I think somebody called the HSE into this one because they were quite worried. They would see that and they would call an engineer, they would get an emergency crew, and the only way to deal with that would be to flood that with concrete and get that support back into that structure as soon as possible. And I don't think Speedy ever got that digger back off hire. One thing's for sure, no one's ever going to build a basement under that building in the future. The one you see on the left here, that was when the HSE came into our site. Actually, we had a site going in Chelsea. We're digging 9.5 metre shafts there, I think. They didn't really say much, but it was nice to see our photo pop up in the report that they put out back to the industry, just showing some good examples as well. So health and safety is everything, obviously, for what we do. So we get some checklists together. We've got to have our method statements and our risk assessments in place. We would have a checklist that has to be compiled at the start of every shaft and every part of works. Strong confined spaces procedures, because we're in those confined spaces, rescue situations, and we would need to have the calculations for all of them temporary works on site. So some more things here. So temporary works inspection form to inspect that equipment. The lifting gear that you see on the right here for hoisting out, that would be inspected every 6 months. We're doing a drill there just to do a rescue if someone does become incapacitated in a shaft. And then we would have all of our other permits in place, permits to dig, hot work permits, rescue and access checklists, and things like setting out drawings that you have to follow to know exactly where you're going. So here are the type of underpinning drawings that we have. So we're showing in 3D so that everyone can visualize exactly what it is. We've got the plans, the sections, we've got the dimensions and ground types, but we've also got this health and safety checklist. You need to tick every one of them boxes off on the right hand side before you can break the ground, start excavation. And we've got QR codes which take you to a virtual reality environment, augmented reality environments to see these underpinning systems. So the first one has no earthwork supports in it, just get the concrete in there quickly. We've got just some ply lining for shallow pins again. We've got a timber system for shallow underpin shafts. Now we're moving into steel sheets when we get a bit deeper. We've got steel sheets with steel whaler frames, and you can do double or triple frames depending on where you're going. And then we've got our deep shaft systems, and we've got some just some innovations that we're looking at for rounding shafts off because it's quite an efficient shape. Systems like that would be for very firm ground. So lots of different systems in place, but just because we've got a standardization in the types of systems that we've got doesn't mean that you can get away without having a full set of calculations for that exact building, for that exact ground condition. So we need full temporary works design on every job. So confined spaces training, really important in what we're doing. So risk assessments, looking at the hazards, and you would have a top man in place up on top. He would have rescue breathing apparatus with a little bit more air in it. And what you can see Gigi wearing there, he's got a gas monitor on his lapel. We would tie that to a bit of string and dip the shaft before you get in. Then when he gets down there, he doesn't have to wear all that gear while he's doing the excavation works. Of course, they would be on the side, just nearby. And when we get down into deep underpins, we keep the harnesses on. And just over his shoulder there, you can see the rescue winch. That is a manual rescue winch. We would have an electric winch that's in place, but in terms of if there was a power cut, you would use the manual winch to make that escape. Because there's lots of things that can go wrong in them shafts. You can have pipes that you cut through, and there may seem that there's no water coming into them. And then you get a good storm, and your shaft could fill up with water. You could have low oxygen levels, ground gases in that shaft as well. So lots of risks. With all these procedures in place, we can mitigate them quite well. So our temporary works procedures must be to BS 5975. We would have a temporary works coordinator and a temporary works supervisor fully trained on every job. Now that's a 2-day course and a 1-day course, but really it's your expertise in your field that is the most important thing. And these courses just really tip you off with the procedures that you need to be following. So if we're getting into deeper shafts, so the guidance would say that if you're more than 3 meters deep in a shaft excavation, you'll have a check-in engineer. And then we'd have a temporary works register with every single item of temporary works on that project written on it, showing the calculations. Do we need drawings? Who is the temporary works engineer? Who's taking responsibility under their PI for it? And remembering that permit to load, but also permit to dismantle and a sequence to dismantle, because sometimes that can be the most dangerous bit, is getting out of these excavations and getting back out above ground. And filling in those holes and taking out that earthwork supports. So we would have daily records. Them records would be digitalized, and we would have them back at our office so we can make sure that all of these procedures are being followed. So what happens when it goes wrong? There is a person in that shaft there, so I'll just leave that up briefly, but you can see the brickwork fell away. So how about putting in a concrete ring beam around that whole structure there in the first place before you start underpinning the shafts? We've got some different, this is a steel beam just to hold brickwork in place. And this is a system that we like to use a lot. So we've designed this in-house. We got a team together with the people that are on site, and we just wanted a quick and easy way of supporting. It's only a small bit of brickwork that you're looking at supporting, and it doesn't fall that often, but how often is acceptable? If it falls 1 in every 10,000 times, is clearly it's not acceptable. If you're in that shaft and you're doing the underpinning. So that gives us a lot of security overhead while we're doing them works. Right, here we see a sequence for underpinning. So it'd normally be a 1, 3, 5, 2, 4, making sure that you do a pin, you leave 2 out before you do a next one, but ideally even further than that between your pins. And you can see that this is a 4D sequence, time being the full sequence. But if you look at corners like that one there, you can draw them on a plan as a square, and it's very easy to go to work with that, but it's actually more difficult when you get 3 underpin shafts in one corner as how to coordinate them. So you can see the guys here underpinning, that's between 2 pins that we've completed already. So a lot of propping horizontal. You can see the sheet there on the wall from the previous bit of support. But it's great. This one was for a wine cellar that somebody wanted beneath the lobby of their house. And you can really make some amazing structures below ground. It's just important that we follow procedures and do that safely. So one thing to note here, trade association membership, if you're getting somebody to do underpinning works, if you get a PCA member in from a very early stage, then you've got somebody that can manage the waterproofing. You've got a whole load more options in your waterproofing design, not from the right from the outset, rather than waiting until you've finished building that structure. But definitely to mention getting ASUP members in to do your underpinning work. So the Association of Specialist Underpinning Contractors. And because that company, you can be guaranteed that they've been audited very heavily. So new members would have a look at their corporate standing, their identity, to make sure that there's no criminal backgrounds in there. Everybody gets a technical, health and safety and an insurance check. And that company will be checked to make sure that they've got enough finances to do the projects that are underway. So there's also a contractor assessment scheme that could be every year. If somebody is shown very low risk and their procedures are exceptional, maybe that would go out to every 2 years. But they would be checked, and you don't know when them checks are coming ahead. You give a list of sites, you get a random inspection on your site. They would come to our offices, go through all of our procedures, and that's not just the health and safety, but it's the attitudes, it's the management, it's equality in the company, our quality procedures, how we communicate. It's a very thorough check, and it gives peace of mind, I think, to anybody who's looking to get basements or underpinning works done, to know that a lot of that assessment has been done on that contractor already. So let's have a look at some alternatives to underpinning. This is one called Hoop Safe, and I know about this because when I was at university, I wrote my dissertation saying that this could replace underpinning in a vast majority of cases. And I couldn't find much data on it when I was looking up. I was trying to read the old stories that I had from years ago. So I'll just kind of paraphrase and go from memory. I think there was a housing estate of about 40 houses, and the ground investigations weren't done very well. And after people were moving in, all of them houses began to crack up. They looked at underpinning them, and I think that would have been a piling scheme, and the cost was just through the roof. I think that the decision would have been to demolish them instead. I don't think there was a warranty in place, because they probably happened immediately before a warranty would kick in, and the contractor wouldn't have had the insurance in place for that. So a very clever engineer invented this system, and it was called Hoop Safe. It's to pour a concrete ring beam around that structure, and the blue item that you see there is to post tension cables across that. So instead of stopping these buildings from moving, you let them move, but you hold the building together so it doesn't crack. So they're kind of like boats bobbing around in a harbour, and just allowed to move independently. My thesis didn't come around. I said it should have replaced underpinning in lots of places. The last articles I can find are kind of 2000, 2004. So it never came about, apparently. Another alternative is injecting the ground. So this photo here is from GeoBear. I don't know much about this. I'm just aware of what it is. I've seen some really good videos. So you've got jet grouting and geopolymer injection. They can put expansive forces into the ground. So I've seen slabs that have dropped, and they actually inject underneath and raise them slabs back up to the level where they were, raising up corners of foundations like this. But there's just so much beyond my understanding. If you've got desiccated ground, and you inject it, let's say you've got heave back into that. Now, talking to them recently, they say they've got lots of studies into all of that. So I just think it's worth consideration in a lot of places. There's huge cost savings, but I understand engineers wanting to give a definite solution. And if you dig holes and fill them with concrete, you can be guaranteed what you're providing. You can see the ground. You can see there's no roots down there that might damage the building further. So definitely one for more consideration, I think. So underpinner training. On the right here, you can see our virtual reality training that we put in place. So we've got this on the Oculus Prime headset, and you've got a little round circle there in the middle. So you pick your system that you want to do the training on. You can see all the health and safety equipment and the permits that we need in place on the wall, the drawings, and you cover that play symbol, and it will play the underpinning sequence that we're looking to do here. This is an experimental system that we were working towards, just on the idea that the most efficient shape that you can dig a hole is round, because it self-supports to a certain extent, and the earthwork supports are doing a little bit less work than they are in a square shaft. We've got lots of other training that we need to put in place as well. You've seen confined spaces, abrasive wheels, manual handling, lots of different training, as well as your general knowledge on the buildings. And you must appreciate that if you look at a Velux catalogue, they brought around, or a Velux instructions, they did away with all words, and it was just one instructions that can go to any nation. This is the same as that, even much better. It's because obviously it's three-dimensional. You can move around that space. If you tilt your head forward with the headset, you can drop down into that shaft and have a look around. So yeah, it's a really good way of providing this kind of training. We also need to make sure that we've always got first aiders on site, that we've got a site manager on site that knows underpinning, but also has their site management training, SMSTS, cable detection, inspecting harnesses. These are all in our checklists of things. But if we put an ad in and we're looking for underpinners and we write down our minimum requirements, which would be kind of minimum health and safety, nobody's going to reply to that ad, because we just don't have the people out there with the training that we need. And when ASUC come in to inspect our sites, they will go up to the people that are digging the shafts, and they would like to see their MVQ specifically in underpinning, if that's what they're doing at the time. So we go through a period of training. When we get new people on, we're looking to train them up, get them booked in on the courses as quickly as we can and bring them up. But we are training for the industry. It would be nice to see that the people are specifying underpinning, to put that in as a requirement, and you would see a big uptick in training across the board. Here you can see one of our directors, Oscar. He's delivering that training on site. You've got to remember, a lot of the people that come to dig holes, English is not going to be their first language. We've got lots of people who are technically absolutely excellent, very, very clever, highly skilled people, but struggle with English language. And I suspect that they were doing something else if they had good language. So we've got to find a way of providing that training and communicating, which we do. And this kind of system helps a lot. So have a look at this one, underpinning below water. This, we were about maybe 8.5, 9 meters down below ground on a double-story basement in central London. And we took this video to show the design team and the engineers what we were up against. That water wasn't at the level it was expected to be. If we kept going there, and if we kept pumping, you can imagine we're pretty much, it's just a 2 meter square hole. But really, it's like you're in a lake, and if you put 2 or 3 pumps in that, you will just keep pumping and pumping, and it takes a while for the water levels to go down. You'll be taking all the fines away from them buildings that are in the vicinity. So you've got potential to cause huge amounts of damage. And thankfully, in this case, they redesigned. They took us up just about another 4 inches higher, which took us out of that water and mitigated a lot of risk on that job, and of course brought some cost savings along with it. Free lime is one worth talking about, particularly in the dry pack between underpinning and what's above. Thank you for Delta for these images that they sent to us, and for Newton as well for this particular image, which really shows the damage that can happen. So when you're making your cement for the concrete, you've got lots of calcium oxide in that. That's free lime. And then you can see that will dissolve in water to give you calcium hydroxide. So when that comes out in that water, it's run across the concrete. It will then react with atmospheric CO2, and what you've got left is insoluble calcium carbonate. And I can tell you that's free lime, and that's what will choke a basement up. And particularly, it will come through the dry pack. And if you hit that with a claw hammer, it just bounces right off it, and it doesn't even leave a mark on it. It's very, very hard stuff. So what we do to stop that is we want to flush back the dry pack a little bit and put waterproofing in front of it, and we want to put an anti-liming agent across all them concrete surfaces. Now, I'd be talking to the likes of Hudson Lambert from Safeguard, and I talk about the practical world, and he's very much in a scientific world and fully understands what's going on. And he shared this study that he did. So you can see on the left what's happening. That's a cavity drainage membrane that's been completely choked up by free lime. And they made discs, and they coated these discs with anti-liming mixture. And you can see on the right-hand side how much free lime is coming out of the control sample without that. And they're testing a various number of products. But the study on the side, what they did is they extrapolated that, and they worked out how would that work over a 10 meter square section of wall over a period of a year, and they calculated that that would add to 40 millimeters of free line build-up. So that's pretty much choked out your waterproofing membranes. It's a reason that I think if you're designing underpinning, you should put a channel on the outside of that. So 100 mil wide, 50 mil deep. So that will collect, we put in a void former into that, and that would collect all that CO2, and it would give you a long period of life for that building. What I don't agree with is allowing that water to run down the wall and then across a slab to a section of pipes underneath that slab, because I think you're asking any potential moisture. There shouldn't be any water in there, but in the event that someone hasn't done their job right with that anti-liming agent, it's completely clear. You can't really see that it's been put on the walls. Maybe some colorant should be put into them, actually. It might be a good idea just to see it's done. But it's just about reducing risk in design as much as possible. So some advice on selecting an underpinning contractor. If you're looking to do underpinning works and you're specifying for a client, or if it's in your own place, have a look at their insurance. Make sure it says that they can do underpinning works and the depth, and they're covered for that. Make sure they've got a proven track record, lots and lots of projects and photos they can show you. Get some references. Make sure there's a qualified temporary works engineer with PI cover on the job. Look into other insurance as well, like non-negligent insurance, because the contractor really is insured for their negligence only. Look at the RAMs and read them, and make sure what they do is following them, risk assessments and method statements. You would have a temporary works coordinator, look at their certificates. Temporary works a really important part of what we're doing. A building that can monitor that building for movements would be good. Party wall awards, you want a contractor that can put a whole comprehensive document together to make that party wall surveyor sign those works off. So like sequence of works and things like that. You want a copy of all staff training, testing that they want to do on the materials for the concrete. If there's site batching of concrete, then you would need a lot of testing in place of cube samples. If you pick an ASUP member, then you've got a lot of peace of mind. But if they don't have that, then an external health and safety inspection is worthwhile getting in place, like CHAS or construction line. Make sure an F10 is in place. I think if there's more than 5 or 6 pins, it's going to be applicable that you let the HSE know that you're doing those works, and just that they're capable of working in that principal contractor role. Quite important as well. So other guarantees that you can get for works, there's defect insurance guarantees. You can only again get these through ASUP members, but if you want extra insurance, extra peace of mind in place, they would have that guarantee. Is really a latent defects policy. It'd have a 10-year term. It would cover the contract sum, and remember that that's direct between the underwriting insurer and the end policyholder of that document, and it would cover the cost of the works and an additional 25% towards consequential losses. So let's have a look at some case studies on types of underpinning systems that we have and do. So maybe starting with some shallow underpinning. So this is a grade 2 listed building that we're putting underpinning works. I think we had some ply lining in that, but in general with shallow underpinning like that, you wouldn't really need any earthwork supports, just some supports to the structure as per the temporary works engineer. Now, because that photo had that membrane in place, and some people might be a little bit confused by some of that, it's because this was a grade 2 listed building. We had discussions with historical building consultants. They wanted that slab to breathe. They were allowing some membranes on the walls because this had Newtonite, which is old waterproofing, bitumen waterproofing going back really 100 years or more. So that would have a glasscrete aggregate down there. We would just put a hessine material over the top of that and a limecrete slab as well. We've got a drainage layer underneath that. So that was an acceptable solution, and it would just have a certain amount of caveat from our part. This would be a medium-sized underpinnings that we're looking at here. This is how we're using augmented reality. So we're not actually in the room with them models there, but this is not photoshopped either. So this is a view through an iPad, and therefore the iPad detects the drawing and would show the underpinning systems coming up from there. So it's another really useful tool. So when you hand your drawings, just view it through your phone with an iPad, through our own app or just general augmented reality apps, and you can actually walk around and see exactly the design. It's much better than just 2D on paper. This was another job that we had in central London. This is double-storey basements. So these are hand-dug shafts. We can do these down to about 10 metres. If you want to go further than that, then you would dig a much wider shaft in the first place to begin with, and then step back inside that and do another excavation below. This is where there's no room for piling or other options like that you might want to do. So have a look at this one as well. This was quite a challenging project. This is about how to underpin a reinforced concrete frame building. So you can see we've got 2 metre by 2 metre mass concrete foundations. So the way that we did this was piling to either side of that, pouring a ground beam with reinforcement cages each side. We build a structure up over the top of that, a support structure to support into that column. And therefore we can smash out that foundations, and we've re-supported to the sides. That allows us to put a couple of beams in there, steel beams coming across, which get encased in concrete, and we extend our steel structure that you see on the side and the concrete. So we're actually extending them columns down, and as you can see, it gave the head height that we needed within that building to change that from what was just like a garage space into new apartment space. So here you can see the actual job going ahead. There's the pilers piling away, the ground beams going into place, our steel structure going in each side. Now we're demolishing out them foundations, and we were using deck span to break a lot of that way quietly at the evenings. You can see the beams going in there now, wrapping mesh going around them beams, and the extended columns coming down. And then, of course, wrapping those in concrete at a lower level. And that gave just that bit of additional headroom that was needed to make that a more workable space for the apartments that were going into it. And this is the temporary works, the complex steel structures that were going in place to make that go ahead. So just on a final slide, this came up during the week, and the goal here, really the takeaway from this is, if you are doing underpinning works, make sure that you build them in the right place. So this guy on the left built a basement, so he put some underpinning in and he rebuilt that structure, and he's nicked a bit of space. So I don't know if that was accidental or if that was deliberate to land grab, but that mistake is going to cost him over £500,000. So check on the setting out of what you're doing and make sure what you build is completely in the right place. So I've blasted through that very quickly, but that's the end of this presentation about underpinning. So I will say a big thank you for listening, and I will pass you back to Andy.
Well, Cormac, many thanks for that presentation. There is certainly some interesting points. One in particular jumped out to me, but just before I say that, folks, I appreciate there was a little bit of a buffering issue just at the start there. Hopefully it didn't impede your ability to see the slides and hear okay, but just to let you know, there will be a replay of the webinar getting posted out tomorrow at some point, so if you did miss anything, you will be able to kind of catch up on it. But yeah, no, as I was saying there, Cormac, there was a point that did actually jump out to me. It was when you were talking about willows and conifers. I am pretty certain my neighbour, only literally a couple of doors up from us, on the rule of what you were saying about privacy, has literally just planted 2 or 3 conifers. I couldn't tell you for sure, because I couldn't tell you the difference between trees. I would need to kind of Google it. But I'll tell you, you've sparked my interest. You have definitely sparked my interest, just out of interest, my own benefit. How far away do you need to be from a conifer tree that you're at no risk of any issues?
Yeah, I mean, there is no hard answer to that. But if you just Google the tree root profile, you'll see what a standard tree would look like. But if that tree is getting lots of water where it is, you can grow trees on a very, very small root ball. But if that tree has to search out water, they will go far and wide. So you need to speak to an arboriculturist, but I would just give your neighbour a heads up and just make sure that they crop them down. I think if you top them after a couple of years, they tend to go outwards, but it's not speciality in mine, the trees.
All right, well, interesting stuff. Well, folks, many thanks for those that have been sending in questions via email and via the chat. You still have an opportunity if you do want a question posed. If you do, just simply go to the chat facility and ping it over. But if I fire into the questions now, and Cormac, if I can ask, if you can try and keep the answers as short as you can, because there's quite a few questions. But I'll start off with Paul Green. Paul Green's asking, is there a recommended minimum depth that trial holes need to be dug to?
No, well, you're looking to find the foundations normally only. The information on the foundations, it would be, ground investigation could go down to about 10 metres, but there'd be bore samples that people would be taking. The one thing I'd advise is when you get to the foundations, sometimes it looks like you've reached the bottom of the foundations. If you get a steel bar and you just tap it in underneath to make sure it's definitely soft underneath, and you're not got additional foundations below that. So trial holes until you find the foundation, soil investigation down to about maybe 10 metres by specialists.
Okay. Well, do you know, I was about to move on to another question there, but there's a question that's just come in from Richard Hooper that actually links to what I was just about to ask, which is Richard's asking, what is the definition of a shallow traditional underpinning? E.g., what depth up to do you need to still go down to effectively that's classed as a shallow traditional underpinning?
Yeah, so I would call it shallow. I'm thinking about our temporary works only. And I'm calling it a shallow system. So very shallow systems, you can use timber only to support that. And when you get down, so to me, a medium depth to me is 3 metres, and that's quite a normal standard kind of a shaft to do, and it doesn't move you into the realm of checking engineers on calculations. So that's why I would label 3 metres maybe as shallow, and down to as low as you need to go just to lower them foundations.
Well, sticking with the theme of shallow foundations, and I do apologise to the person that posed this question if I say your name incorrectly. I think it's pronounced Faranaz, I think it is. Well, anyway, Faranaz is asking them, when underpinning in water, if the water keeps coming in, how do you carry on with the works?
So, yeah, I had so many slides that I had to get rid of. It's a difficult one. So you can't inject in all sides and below to stop that water coming in. And obviously, if you don't inject below, it will just keep coming up. We've had cases before. We went for a 9-month party wall section. So you weren't going to revisit that, but we agreed to underpin below the water table. And we did that by digging a shaft. And then inside that, we drove sheets vertically down into the ground. So we left the water in there. We were able to get the soil out, leave the water, and you pour the concrete with an anti-washout admixture into it. So there's special concrete designed for those situations, and you pour into that concrete and you just let it swell and displace the water, and you pump that away. So that was just for a shear key going below the foundations.
Right, okay, well, interesting stuff. We'll sticking again with this theme of shallow foundations and flooding. David's posing a question that for shallow underpinning levels, is the flooding method acceptable, and how can we be assured that there are not any cavities between existing foundations and the new pins that are present?
So yeah, this is about when you underpin, you stay down about 1 brick course, so you stay about 75 mil below the foundations. You let that concrete settle because it shrinks down a little bit, and then you would dry pack the gap in between it. So there's another technique that people use, and you just put a little bit, put the shutter high, and you flood it with concrete, and you let that concrete flood to the top. So to me, that's not acceptable. You don't know what's going down underneath there. You don't know if there's an air pocket underneath that. So, and also when that concrete shrinks, it will pull the building down with it. So if you want to make sure that you're getting rid of millimeters of movement at every opportunity, it should be dry packed and not flooded, in my opinion.
Okay. Just a wee quick shout out to Tim. Many thanks by the way, for following up that conifers question that I had just within the chat there. Much appreciated. But moving on, next question. Next question actually comes from Mark Rashard. He's asking, all the subsidence claims that he has been involved in, have pretty much been remediated by drain repairs and or tree vegetation management. I suppose what he's asking is how commonly used is underpinning when resolving subsidence issues?
So I think for insurers, it would always be a last resort because it's very, very expensive. The damage was caused by a reason. So if you can get rid of the reason, the cause of that damage by repairing drains, but most of it's done by trees. So if you've got a house and then someone plants a new tree, the tree causes that damage. If you manage that tree or remove that tree, then you've got that building back into a situation, just do structural repairs and it's fine. So yeah, you don't need to underpin that often, but you can get cases where there was a tree that's been there before the house, and then that tree dies or gets removed and you would get heave coming up into that building. That's a different situation. So underpinning is happening less and less by insurers, and it's probably a good thing. It's just that policyholders have got to deal with a longer period of dealing with them cracks and wait for that building to settle back after the trees are managed.
All right, okay. Well, here, Patrick Harvey Blake has just, sorry, my apologies. Gavin Young has just posed a question quickly off the back of just you mentioning about what to do if it keeps on flooding within a pit that you're going into. Now, it's to do with the different types of concrete. When you're working within underpinning and shoring up underpinning situations, is there specialist concrete that you would typically use?
Yeah, I mean, the concrete would be specified by the engineers. We wouldn't be specifying that. That's permanent works under their PI. But given the conditions that we might come across in the ground, like if there's sulfates that come out in that report that you did on the ground, then a sulfate resisting cement would be required, which would just be a much stronger concrete that's able to resist that. So yes, there's anti-washout admixtures. Sometimes we do underpinning and there's just never going to be any access in there. And you can get free flowing concrete that you don't need to vibrate. And again, it's more expensive, but it takes that whole process out of it. So there's lots of different options there for certain situations. And yeah, the engineer would normally specify, and we would advise on workability only, buildability.
Well, Cormac, this is maybe more of a personal question for myself, but it also runs onto a theme of what a chap by the name of Anthony Cathcart asked also as well. Now, say we shore up the foundations and we use the right concrete and it's all settled. Is it then just a case that you've then got to prop up the building? Do you literally need to jack it up, or is it enough by just shoring up the foundations that it's enough to just keep the building where it needs to be?
So in most cases, you just accept that movement has happened and you deal with it. So you underpin it and you secure it and you keep it where it is. There is it's a specialist thing to jack a building up. If you have a look at pouring that concrete ring beam around the building, you would need to do something like that to hold the building together to be able to jack it up. Because if you just put a jack under one spot, then you're creating a point load of force that will just make the building crack and move even more. So it happens. Specialists even move buildings from one location to another. So it's all possible. And when it gets to ground injection, that's another specialty, and it's outside of my realm of understanding. I think it's fascinating. I love what they do. I don't know the limitations of it, but it happens and people are able to do that.
Well, folks, if you do know this, if you do have a comment there that you want to kind of throw into the mix, certainly feel free. We love to hear other people's opinions. So if you want to kind of add value just to what Cormac was just saying there, then get on the chats. But yeah, next question. Next question actually comes from Patrick again, Patrick Harvey Blake. He's asking, what assurances do lenders need to provide a mortgage when purchasing the house? I'm assuming what he's meaning there is if there's subsidence issues that have been recognised.
Yeah, so a mate of mine came to this and he said, look, that's been underpinned. That's an issue for insurers. I think it's a good thing that it's been underpinned. You know that section of the building, if the whole building has been underpinned, it's great. Problems come when you've got foundations that are at different depths and it's quite often dealt with by transitional underpinning. So the underpinning just gradually steps up in depth until it meets the existing foundations. So if it's done right and it's done well, you shouldn't really have any problems. I think lenders should lend on. Definitely, there's been an issue, it's been dealt with, and certainly if you've seen a period of time that building has been stable, then there should be no reason not to lend on it. In fact, it's an improved situation, if you ask me.
All right. Well, we seem to have a sharp-eyed individual that by a chap by the name of Jim Perman that's picked up in one of your pictures that's within your presentation, and he's asking on one of your images, the underpinning shafts that seem to be in the picture looked rather large. Are they meant to be that big, or are they fixed sizes or suggested sizes in terms of shafts?
Yeah, I mean, it's an issue for us that we get lots of drawings and they say, so underpin shaft 1 meter maximum width. But we've got to get in them shafts. So that's historic how it was. And years ago, people weren't putting much supports in there. But if we put steel sheeting on either side, and then we put whatever the engineer would design, probably a double, at least 100 mil of timber, we've got only 700 mil left to dig in. Now, we're not using a bucket and a rope anymore. We're using a winch and a steel rope. So that's about 500 mil wide. So there's no space in the modern world. There's no space for us to do narrow, small shafts. So we want them to be wider, certainly wider than at least 1.2 and wider than that. And the issue, I think, for a lot of engineers is the brickwork spanning over the top. That you can't really ask brickwork to span more than a meter before that would begin to collapse. So you put lots and lots of temporary works in place. To me, particularly on the deeper shafts, we're looking for them to be 2 meters wide, but they are a fully designed steel shaft system, and I think you're giving a lot of security to that building by doing it. And when we're doing it in them particular cases, we would pour a concrete ring beam to at least half the thickness of that wall around the whole of that structure. So you're giving a lot of security to that structure. So to me, underpinning shafts need to be designed and fit for purpose, not to a given width.
All righty. Well, I've only got 2 quick questions I'm going to hit you with before I start doing the kind of wrap up. I apologise if you haven't had your question answered, folks, by the way, but I will hoover up all your questions, and if Cormac can answer them, I'm not making any promises, I will pass them across, and if you can get back to you, then great. But next question comes from Richard Crossley. Richard's asking, what does Cormac think about pre-applying Type A to underpin? I'm assuming he's being Type A waterproofing.
I think, yeah, it makes a lot of sense. So you're not really pre-applying it to the underpinning. You're sticking it to the earth, and then you're pouring your concrete against that. Which is sensible to put a barrier. You've just got to make sure that connects at the top and the bottom, and the construction joints are quite difficult to deal with on that. So it's a system that definitely you put in, definitely can help, but there's a lot of risk that comes with it. The quality control can't fully be there on that. So if you can get an inexpensive system, then I'd advise doing it. I think it can help considerably depending on the job. But remembering when we do it, it's the concrete that we're relying on. If you put your concrete in and you get your quality control really good, it's the concrete that I trust to stop the water coming in more than the waterproofing itself.
All right. Well, last question there. Last question comes another one from Paul Green. This is principally to do with compaction. So given the difficulty on good compaction, vibration of concrete in confined spaces, do you recommend self-compacting concrete and underpinning?
Yeah, I definitely think it's worthwhile. We've got to manage the expense to clients. It's a very expensive concrete. So in most instances, you make sure that you can get that vibration in place. Self-compacting concrete is good, but remember when you're underpinning as well, you've probably got only 2 or 3 shafts ready, and you pour the base and then you wait before you pour the walls. So if you're only ordering sort of 2 or 3 cubic meters of concrete, then you've got 5 cubic meters of empty space in that truck, and you need to pay for that as well. So your concrete cost has doubled, and then you've got the extra space, so you've probably got triple the cost of concrete in there. And if you go to clients, it's great if they can afford to pay that and want to pay it, but we've got to give cost-effective solutions as much as possible.
Well, folks, many thanks just for everyone that fired over some questions. For those that didn't get a chance to get the question asked, as I said, I will send them over to Cormac. Absolutely no promises here, but if Cormac is able to reply to the remaining questions that didn't get answered, then great. So, folks, just in case anyone's looking for any additional information, first place I want to point you across is to answer the Association of the Association of Specialist Independent Contractors. They have a variety of technical guideline documents, technical documents, codes of practice that you can find via their publication library. They also have a variety of specialist training available. You can see the website address just up on the screen. And additionally, if you are looking for anything that's more kind of waterproofing related, you can visit the PCA's structural waterproofing document library. Again, the URL is up on the screen. There is, similar to the ASOP library, codes of practice, technical documents and guideline documents up there. But in addition as well, there is the professional section and the training sections as well within the PCA website that you can explore. I've just sent links to the ASOC the website and also to the PCA library just in chat there for anyone that is interested. Just before we kind of finish up, just a reminder about our upcoming conference coming up on the 14th of July. The 2022 International Structural Waterproofing Conference. We do hope we see lots of you there. It has been a long time since we've been able to hold on to anything like this. If you are interested in coming along, I've just sent a link into the chat there that you can click on just to find out a bit more information about it. It even includes CPD points, so I do hope to see you there. Lastly, just before kind of finishing up, our next webinar, this time we look at the recently revised approved document F update. Will it finally ensure proper ventilation in existing homes? This is taking place on a slightly different day rather than the Thursday. It's Tuesday, the 28th of June. Again, I've just stuck the link to the webinar just within the chat there. If you are interested in coming along, we hope many of you do, then feel free to register. Last but not least, I just want to say, firstly, a big thanks to everyone that joined us this morning. Secondly, a big thanks to yourself, Cormac, for the great presentation. It really was a great presentation, mate. And lastly, I just want to say a good morning to everyone and many thanks for joining us. Hopefully, we will see you on the next live webinar in a couple of weeks' time. Good morning, everyone, and goodbye.
Thank you.